Hi students, in this video I give you the detailed explanation of radial and tangential component of acceleration of a particle in circular motion. The theoretical part is given in our website. This is free for all the students. The link of this part is given in the description box. Here we consider two mutually perpendicular axes, that is x prime and y prime, and O is the origin. A particle rotates in a circular path about point O. At any instant of time, the position of the particle is P. Here, the radius, that is OP, this is equal to R. The radius creates angle theta with positive x-axis. We consider here another coordinates, that is we consider two perpendicular axes, that is x1 prime and y1 p at point P. Here the line drawn along PA, that means OP to PA, this indicates the radial direction, and PP, this is tangential. At first we have to calculate the unit vectors here at point P, that means towards radial and tangential direction. Then we have to calculate the position vector at point P, which is a function of time. Then we have to differentiate that position vector with respect to time, then we get velocity. Again, differentiation of velocity with respect to time, we will get acceleration. The radial component at point P, this is PA. Here PA creates angle theta with Px1. Therefore, the component along Px1, this is PA cos theta, and along Py1, this is PA sin theta. Here I cap and j cap are the unit vectors along x-axis and y-axis respectively. Therefore, we can write that PA prime, this is PA cos theta I cap plus PA sin theta j cap. We know that if A is a vector, then the unit vector is represented by A cap is A vector by mod of A vector. Therefore, the radial unit vector this is ER cap, this is equal to PA vector by PA. Therefore, this is equal to cos theta I cap plus sin theta j cap. We know that the radial component and tangential component both are mutually perpendicular. The angle between PA with y1, this is 90 degree minus theta. This angle is 90 degree minus theta. The tangential component, that is PB, it creates angle 90 degree with PA. Therefore, the angle between PB with y1, this angle is also theta. If we resolve PB along y-axis and x-axis, then in y-axis the component is PB cos theta, and in x-axis the component is PB sin theta. Therefore, the tangential component this is PB, this is PB sin theta, this is the x component, and this is along negative x-axis, therefore this is minus I cap plus PB cos theta, this is along positive y-axis, for that reason this is plus j cap. The unit vector along tangent, that means the tangential unit vector, this is et cap, this is PB vector by mod of PB, this is minus sin theta I cap plus cos theta j cap. Therefore, we can say that whenever a particle is in circular motion, at any instant, the radial unit vector, this is cos theta I cap plus sin theta j cap, and tangential unit vector, this is minus sin theta I cap plus cos theta j cap. The particle is at point P at any instant of time t. Therefore, the position vector of P, that is OP vector. OP vector, this is R vector. Here R vector, this is equal to OP cos theta I cap plus OP sin theta j cap. Here, as OP creates angle theta with positive x-axis, then this component, this is OP cos theta, and the component along y-axis in this direction, this is OP sin theta. The magnitude of OP is R. Therefore, we can write R vector, this is R cos theta I cap plus R sin theta j cap. Now, to calculate velocity, we have to differentiate this equation with respect to time. Then velocity of the particle at time t is v. This is d dt of position vector, that is d dt of r. So you can write that d dt of r cos theta I cap plus r sin theta j cap. We can write this equation like this: v, this is r as the radius, this is constant, then r in bracket d theta of cos theta into d theta dt I cap plus d theta of sine theta into d theta dt j cap. Therefore, V, this is equal to R, differentiation of cos theta with respect to theta, this is minus sine theta, and d theta dt, this is omega angular velocity I cap, plus differentiation of sine theta with respect to d theta, this is cos theta into omega into j cap. Therefore, we can write that V, this is R omega minus sine theta I cap plus cos theta j cap. So V, this is R omega, this is minus sine theta I cap cos theta j cap. This is the tangential unit vector. Okay, so we can write it as this is E t cap. Therefore, the velocity is directed tangentially. That means from point P to B, and the speed is defined as V. This is R omega. Next, we want to calculate the acceleration of the particle. Here the acceleration A, this is d dt of velocity. Therefore, this is d dt of R omega minus sine theta I cap plus cos theta j cap. Therefore, acceleration, this is equal to R, this is a constant term. Now, differentiation of omega with respect to time into minus sine theta I cap plus cos theta j cap plus R, this is constant, and here omega is also constant, then differentiation of sine theta and cos theta with respect to time. Therefore, d dt of minus sine theta I cap plus cos theta j cap. So we can write this equation as acceleration, this is R d dt of omega minus sine theta I cap cos theta plus cos theta j cap. This is the unit vector along tangent. Therefore, we can write it as E t cap plus R omega. Here the function is theta and we have to differentiate it with respect to time. Then we can write it as like this, that is d d theta of minus sine theta I cap plus cos theta j cap into d theta dt. So acceleration, this is R d omega dt e t cap plus R omega. Here d theta dt, this is also omega. Therefore, R omega square, and differentiation of sine theta and cos theta here, this is minus of differentiation of sine theta with respect to theta, that is cos theta and I cap, plus differentiation of cos theta with respect to theta, this is minus sine theta. So minus sine theta j cap. Then this equation we can write as A, this is R d dt of omega e t cap minus R omega square cos theta I cap plus sine theta j cap. Therefore, this is A r d dt of omega et cap plus r omega square. This is unit vector along radius. So this is E r cap minus the unit vector along radius. This is E r cap. This is cos theta I cap plus sin theta j cap. Therefore, here this is minus E r cap. Therefore, the acceleration having two components. One is tangential component, that is at into et cap. Another is radial component, that is ar into minus of E r cap. So here from diagram we can say that whenever the particle is moving in a circular path, there are two components of acceleration. One acceleration is towards the center along radius. This is AR. Here the direction of radial unit vector, this is from P to A, but in acceleration there is a minus ER cap. Therefore, this is A to P, that means towards the center. And another part, this is tangential part. This is along P to B, the acceleration here. This is AT. So we can write here that AT, this is R d dt of omega. Here we can write it as d dt of r omega. This is d dt of v. Whenever the particle moving with constant speed, v is equal to constant. Therefore, at, this is differentiation of velocity, speed with respect to time. This is also 0. Therefore, for constant speed, whenever the particle moving with constant speed in circular motion, then the tangential acceleration is 0. Only the acceleration is acting here. This is radial component. That AR, this is R omega square, or we can write it as R. Omega is V by R. So this is V square by R. This acceleration is known as centripetal acceleration. And from diagram, we can say that there are two components. One is along radius, another along tangent. Then the resultant acceleration of the particle. Then we have to draw a parallelogram here, and the diagonal from point P. This represents the resultant, that is A. Here, as tangential and radial component are mutually perpendicular, therefore the acceleration, this is root over of at square plus ar square. And if the angle here, this is, if the angle is phi, then tan phi, this is at by ar. So whenever a particle moving in a circular path with non-uniform speed, then there are two components of acceleration. That is, one is along tangent, another is along radius. Here I give you an example how to solve numericals of circular motion. Now in this question, that a particle rotates in a circular path of radius 4 meter. The speed of the particle varies. That means v is equal to t square. Here t is the time. And we have to calculate the acceleration of the particle at t is equal to 2 seconds. As the particle is moving with non-uniform speed, therefore there are two accelerations. Suppose at any instant the particle is at point P here, one acceleration, that is radial component here, and another component, this is tangential, this is at. We know that the radial acceleration AR, this is v square by r, and tangential acceleration at, this is d dt of v. As v is equal to t square, then we can write that radial component here, this is t square to the power square by r, this is t to the power 4 pi r. Therefore, this is equal to 2 to the power 4 by 4. This is 16 by 4. This is 4 meter per second square. So, the radial component of acceleration of the particle is here 4 meter per second square. The tangential component, this is at, this is d dt of t square. So this is equal to 2t. Now at t is equal to 2 seconds, the tangential acceleration, this is 2 into 2, this is 4 meter per second square. Now we can draw a parallelogram here. The diagonal from point P gives the resultant acceleration A, and acceleration A, this is root over of at square plus ar square. This is equal to root over of 4 square plus 4 square. So this is 4 root 2 meter second to the power minus 2. Now if you consider the direction here, then the resultant acceleration creates angle theta with OP or radius. Therefore, tan theta, this is at by ar. Now at time 2, the tangential and radial acceleration are same. So this is 4 by 4, this is equal to 1. Therefore, theta is equal to 45 degree. Now, from this method, we can calculate the radial and tangential acceleration of a particle at any instant.